Okay, today we are going to start chapter 12, our final chapter. We're going to be looking at inference for linear regression. We're going to start today with a little intro activity. Um, so, so basically what we're going to be looking at in this chapter is we'll be starting with scatter plots. All right, so when a scatter plot shows a linear relationship between a quantitative variable x and a quantitative response variable y, we can use a least squares line fitted to the data to predict y for a given value of x. So you can hopefully remember that work from much earlier in this year, back in trimester 1. Now, if the data are a random sample from a larger population, then we could use statistical inference to answer questions like these. Is there really a linear relationship between x and y in the population, or could this pattern we see in the scatter plot just happen by chance because of our random sample got things that kind of looked linear even though they're not? Or we could answer a question like, in the population, how much will the predicted value of y change for each increase of 1 unit in x? And what's the margin of error for this estimate? So in 12.1, we're going to learn how to estimate and test claims about the slope of the population or true regression line that describes the relationship between two quantitative variables. So what we're going to do is we're going to start with the helicopter experiment. So basically, since we are not all together, we're going to use data from my class last year, but let me explain where this data came from. So we made 50 copies of a paper helicopter that kind of looks like this once you fold it together. And we collected data after dropping it. So we made 50 of these helicopters. We then randomly assigned 10 of them to each of 5 different drop heights. So for example, we numbered them from 1 through 50 and then decided to drop them from these various heights, and then randomly selected 10 numbers to be dropped from this height, and then 10 unique numbers for this height, and so on until we had 40 of the 50 assigned, and then we said the remaining 10 are going to be dropped from 9 feet. And then we split up into groups and dropped the helicopters from those heights and recorded their times. So basically I had a big table on the board, and then each group came in and filled in the 10 times they got for their 10 different helicopters, and they dropped each helicopter once. And here's kind of how these helicopters work. Is as they fall, this is the bottom, these rotors make it spin and drop slowly. So it kind of looks like this when you drop it. So that's a completed helicopter, kind of. And you can see it spins as it falls slowly to the ground. So that's how these work. So then they got all of these times. So here's, when they dropped it from 5.5 feet, here are the 10 different times for their 10 different helicopters. And then all the 10 helicopters that were dropped from 6 feet, here are those times. And so what I did was I took this table of data from my class last year and I gave it to you guys in the worksheet. So if you download the worksheet for today, you can see that my class last year already did these first 3 steps, so there's nothing for you to do here. And then here is the data that they got from their 5 different drop heights, and then 10 planes from each height, for a total of 50 different height and time combinations. But after step 3 is where you guys will start working with this data. So you'll need to make a scatter plot of the data from the previous step. One thing to be careful of here is that oftentimes I hear people say that if time is one of your variables, it should go on the x-axis. That is not the case here, because we set the heights ahead of time, and then time was dependent on height. So the explanatory variable should be height on the x-axis, and the response variable time should be on the y-axis. So you make your scatter plot, then use your calculator, find a least squares line for predicting descent time from drop height. Here's a hint on how to use your calculator to do that. Interpret the slope. Hopefully you remember how to do that from way back in chapter 3, I want to say. And then tell me if you think it's plausible that there's no real linear relationship between these two variables. And obviously we won't be able to discuss this as a class. But once you finish that worksheet, you can take a photo of it and upload it to MyHA. So give that a try, and then if you have any questions on it, please send me an email.